Very good morning to everyone. Dignitaries on the dais, resource persons of this FDP, and most importantly, the participants from more than 15 various organizations across India who have registered. On behalf of the Civil Engineering Department, Symbiosis Institute of Technology, STLRC, Symbiosis International University, and Bentley Education, I welcome all of you to this August gathering. At Civil Engineering Department, we strive hard to impart knowledge of the latest technologies not only to the students but also to the faculty, and this FDP is one such initiative. Bentley Education and SIT collaboration dates back to 2017. Since then, we have successfully launched various activities including certificate program, validation courses, then we've arranged expert sessions, and then we have also conducted events, competition for the students across India along with Bentley, and we have also been given access to Bentley software suite for faculty and students. So I once again welcome all of you and hope this 4 days of FDP will bring a lot of clarity. It will be an eye-opener for all the faculty members to take the civil engineering ahead one step, and I wish you all happy learning for the next 4 days. Thank you for coming.
For example, in civil engineering, we have sensors, we have reinforcement learning, we have artificial intelligence as well. And I think that that's what I was asking Mr. Patil, that is really today's talk also, where Bentley is providing digital twin solutions. Digital twin is impossible to build up without IoT, without AR, VR, and without artificial intelligence. So I think that's a great combo between civil and AI. And one way also it is useful because perception wise civil engineering is slower, all the projects always gets delayed, and AI is very fast, so marriage between AI and civil will definitely speed up the process. And I'm sure everyone knows about the digital twin technology, at least at the overview level, whereby it creates the digital replica of the entire project, and you can control, monitor, optimize everything sitting at your home. So your so-called blue collar job of civil can be a white collar job, and that is one of the attractions to the students nowadays. They want only white collar and only screens.
So first of all, thank you very much to Dr. Kotecha and his team for inviting us here. So we really appreciate for the opportunity. So specifically, I have tremendous respect for profession of civil engineering, because I have a theory that civil engineers are responsible for creating memories, okay? The memories which last forever. So imagine thousands of years after we are left this planet, in a good way or bad way, some another intelligent species is going to come, dig through the dirt, and what are they going to find out? Are they going to find out your mobile devices and mobile towers and cars? Probably not. They are going to find out all the infrastructure which you guys are building today, right? So you are essentially representing the civilization. They are going to figure out who we were based on what you build. But there is a fundamental thing which is supporting the entire thing. So you take any of these initiatives and they all are supported by digitization. That's the need of the hour. And when we talk about digitization, the state of digitization is happening at in the various silos. So your surveying department might be using GIS and reality modeling. Your design department might be using 2D and 3D modeling. Your maintenance department might be using IoTs, but they are not talking to each other. That's what we are seeing in the industry. So if you kind of plot a diagram across your life cycle of a construction infrastructure project, and you look into maturity, the green dots will vary based on what kind of project you are looking at and where the project is and which project you are looking at. But the red dots is where what we are seeing is always the state. Whenever it comes to handing over the data from one department to another, or one contractor to another, or one life cycle phase to another, it always comes back to paper-based handovers. So that's where the digitization fails. This is what we are seeing in the industry today. So I like to tell a story. So imagine you are a king or a queen and you have a daughter who you need to get married, right? Like you need to marry her off. So what are your options, right? And let's assume that we are very traditional. So we are going to ask for biodatas from various princes, right? From grooms. So, and now you imagine that because you are a king and you have a beautiful daughter, you are going to get flooded by a bunch of biodatas, right? How do you decide which is the right groom for your daughter? That's the challenge, okay? And then I come along, I'm the wizard, and I tell you, oh king, don't worry. I'll give you more information beyond the biodata about each and every candidate, okay? So we are looking for the ideal groom for the princess. I say beyond the biodata, I'm going to give you each candidate's LinkedIn profile information, okay? So you now know a little bit more about each candidate. So will you be able to make better decision than just looking at the biodata? Yes? Yeah, okay, all right. What if I also give you their Facebook information, access to everything they have on Facebook? Now you will be able to weed out little more candidates, right? Because LinkedIn, everybody is very nice. Everybody is very professional, right? But then you look into what they are doing on Facebook and you get to get a little bit more realistic picture of themselves, right? So then I say, okay, I'll give you all their private chat history, right? All the access to their WhatsApp chats. Now you know the candidate a little bit more, right? And the kids in the background, you can think about like you being the princess or you being the prince, right? You are also making that decision. Now you have a better decision. I give you their travel history. I give you all the payment history. Where are they ordering food from? Where are they spending their money on? Okay? Will you be able to make better decision about a person than just looking at their biodata? And then finally I give you their entire search history. Okay? Now you know exactly what they are. Right? And that way, the king, the queen, or yourself will be able to make a much better decision about the person. Right? So the king does the same thing and marries his daughter off and they live happily ever after. Right? Why? Because king had access to all the information. So what did we do? We actually created a digital twin for each candidate by bringing in information from multiple places, aligning that information and letting the king make a better decision. That's the crux. That's what digital twins are. They bring in the information from multiple places. Now, unfortunately, about bridges and tunnels and roads, not about princess and prince. And they allow the engineers to make better decisions. That's all. That's all you have to remember from this talk, if anything at all. Okay, so back to the boring stuff. What are we doing then? We are taking information about the GIS, where the particular asset is located. We are taking all the drone captures, the reality data. We are taking the terrain subsurface models. We are taking the 2D drawings, 3D drawings, all the way to the operation and maintenance data coming in from IoT systems, and aligning that so that the engineers can make sense of that information and make better decisions. So that's what Bentley is enabling when we talk about digital twins.
So the infrastructure development is the foundation for any country's economy and prosperity, and that helps in improving the quality of its citizens' life. A rupee spent on infrastructure development has a multiplication effect of 1.2 to 1.5 times the GDP, which will help to propel the economy further. So probably if we come from the economic perspective, so that's more important to understand why we are all talking of these innovations. So there was a long list of the 10 infrastructure sectors. I tried to segregate them, and now let us have a look at it if this makes sense. So this was our main intention of why we wanted to talk of digital twins, water and transportation. I am not talking that we should not do survey, GIS, energy, MaxUp. We have a lot of products there. That's anyway available. So this is the sector which is going to, that's the reason I talk of doing a digital twin in this part and innovation. So it is purely driven by the Indian market, the economy and the industrial scenario. First thing is shape curriculum with the latest industry trends. There is a gap between industrial practice and what we are teaching, because I don't give anybody a blame. The syllabus was made 20 years ago, it is thought it is relevant, now also it goes on. And probably what the universities don't do is they don't incentivize a professor to create a curriculum. A professor's job and full-time paid, take your class, set the exam papers, mark your answer sheets, you are done. So that is an educator's job. Is there any professor whose full-time job is shaping a curriculum, changing the curriculum? That has not happened in the past decades or so. Happens slow. So shape the curriculum with latest industry trends. So exposure, a link between academia and industry. That was my first part. Second part I touched upon, industrial practices. How do I shape it? So follow the money. That's my second mantra. If industry is doing that, what they are doing, so put that in curriculum. You know, the IT department, which is very successful, India has done exactly that. 5 years ago, you knew that the best thing is computer science engineering. Now you know they have other streams, computer science with AI, computer science with ML. So they are creating different branches of it. This is purely based on the market demand. Probably the civil and the architects should look at it that way also. So another part is increasing the visibility. The projects which you do, is the industry looking at you? Are you running a competition with a partnership with the industry? So that's the visibility part we have to do. And the workshop with the industry partners. So here I am, this faculty workshop is for everybody, but I know you are coming from different universities. I'm already working together with VIT. VIT has set out a plan. You will hear more details from Dr. Madhumati. We are also working with Dr. Shaili in Symbiosis, and I'm open to hear anybody's suggestions. Probably we to a LICMAR and any other institute who wants or helps to put that curriculum or whatever in place. But that's the demand of the day.
But I wanted to start, before talking with digital twins, to do a couple of things, to talk a little bit about the industry, right? And then talk a little bit about this step that came prior to digital twin, which is essentially building information modeling, or BIM, and then move on to talking about digital twin. So hopefully the next 15-20 minutes I can do all of this. One of the things that we should all be aware of is that when we talk about the infrastructure industry, this industry is beset by time and cost overruns, right? So there was a recent study that was done, not recent, maybe it's about 4 or 5 years ago now, done by the Project Management Institute, PMI, along with this consulting firm called KPMG. I think that report is available in the public domain. I think several of you may have already seen that report. I refer to it quite a bit in my talks. What people have done is they've taken actual data from places like the Ministry of Statistics and have looked at the performance of projects across sector, public sector, private sector, infrastructure, residential, commercial, whatever. And whichever way you look at it, projects are delayed and over budget, all right? And the extent of delay and sort of overruns are just shocking, right? So for instance, you see that, in this pie chart, 1 out of 10 projects, right, finish on time, okay? And the average delay is about 80%, right? In other words, if it's supposed to take 10 months, it ends up taking 18 months, right? So we're almost talking about a doubling of the time period on projects. Similarly, with regards to cost, maybe 1 in 3 projects seem to finish on budget, right? 2 out of 3 exceed budget, and they exceed budget by, they essentially get to about 2.5 times the initial costs of a project, right? So again, if it's going to be 100 crores, you end up at 250 crores. Right. So this report card is quite worrying, right? So we don't want to be part of an industry where our success rate is somewhere in the 10 to 30% range, and our error rates are close to 200%, right? So the question that people ask is, why is this happening, right? What is the problem, and therefore what is the solution? So there are all of these kinds of things that people will tell you. But the one thread that cuts through all of this, right, is essentially all of these are coordination related issues, right? All of these are coordination bottlenecks. And so therefore the problem is coordination, right? We are a very fragmented industry. The question that we need to ask ourselves is there a better way to coordinate? And so essentially, in order to implement, whether it's BIM or digital twin, you need both process as well as technology, right? And the process is, in my view, even more important. The technology already exists, right? People in the world already have this sort of that you can either license or buy or whatever. But unless you create a process around how you use that technology, you will not really see the benefits. And when you don't see the benefits, people start saying, oh, the technology doesn't work, it's overhyped, etc., and then it sort of falls by the wayside. And you go back to my first slide where you have time and cost overruns, right? Now, the big plus that the digital twin environment comes in, and I like this part on the left a little bit, where we are talking about there's a physical object and a digital object, right? So the BIM model spoke almost entirely about the digital model of a building, right? So you built these digital models in BIM and you did all kinds of interesting things. But let's not forget that there is actually a physical model that we're actually building. And what the digital twin essentially does, over and above what you could already do with BIM, is that as you see on the bottom left there, the physical object and the digital object actually now start talking to each other, right? In a way that has not happened before. Now, earlier, the problem was the physical and the digital were completely detached. But today, if you look at the amount of instrumentation that is going into a building, right, the number of sensors, for instance, that people are putting in for all kinds of things, carbon sensors, strain gauges, etc., sensors to detect moisture and therefore leaks, all of these kinds of things, you now have an intelligent physical object, which can now be very easily paired up with an intelligent digital object, such that they can actually transfer information back and forth, right? So the physical object has digital data that it transfers into the digital object. The digital object then can run a series of scenarios and transfer that data back into the physical world so that we can manage our assets more effectively.
Right now, if you go to our website, csci.edu, you will find already many projects that we have worked on and are still working on. So within these few years, we really have something to show. One of the most important are digital twin KONAS, and I will mention a bit more Design Engineer Construct, a project with schools that we have, digitalization of our new building in the campus, where we are basically developing digital twin from the design stage of the building. So from all those projects, I will focus a little bit more on those three. So the way we are working these days is we set the targets for so-called Smart Campus Initiative, where we want to create a system where our university facilities and the city that university operates in, the city of KONAS, are used for education, for research and innovation. So we want to create these open data sets with different information layers that researchers and students can use for their works. And of course, we cannot do it alone, so we are developing it with our partners. We're involving different stakeholders in this exercise. We are trying to focus on different demonstrations. How can we showcase, how digital twin might look like? We want to make data open and accessible, and we work at different scales, from city scale to campus scale and building. And of course, we use the same ecosystem, the same smart campus system for our projects, research projects that we do. So on a city scale, we have quite a large area of the city scanned, or photogrammetrical model has been developed for the large part of the city. And in that model, we can already we can use that model for different cases. We are showcasing the student works, the heritage buildings, maybe the buildings that are not longer there. So we can add historical buildings into the model of the city. We work also with preservation of heritage. So if we see that some buildings are degrading, these can be scanned and preserved in a digital format. And we also are trying to visualize the data, how, for example, energy consumption in a district can be visualized in these 3D models. And this is in 2 languages, so Lithuanian and English. But I also wanted to showcase how we structured the digital aspect in our studies. So on the bachelor level, we are thinking that we want our students to learn what is building information management, what is digital environment. They should be able to create the model, to select all the attributes, and basically from conceptual design to construction. And on the master level, we are thinking more about IoT, on machine learning, real-time operational data, predictive maintenance. So I would say that at the bachelor level, we are aiming for basic understanding and skills in BIM. And on master level, we want them to be able to analyze the data, to synchronize, to work with different tools, predictive tools, and things like that. So our students received few awards on different scales from different Lithuanian contests on smart cities to some international awards working with digitalization. So I think overall this whole initiative is really paying back. And another initiative that we are really proud about is Design Engineer Construct. It's a curriculum for school students. Why I'm mentioning this, because basically we are giving the same tools, the same knowledge to school students who are thinking about their career, maybe in architecture or civil engineering, and they are working on their projects for the whole year. So right now we have 6 schools that are enrolled, a total number of 200 students that joined this initiative, and some of them are already joining this challenge for 2 years or 3 years in a row. The program is running for 4 years, and we had already 5 challenges under this program. So this is, you can see what students are creating. We did a concert hall with recording studio. They designed 1 year, and then the next year they designed a center for climate change education. And this year they are designing an SOS camp, or a camp for temporary displaced people due to war or climate events. So if we have time, or maybe if not, you can find some data about this project with schools. If you search for KTU and DEC, you will find some recordings. Some of them are also in English or with subtitles. So this is a really interesting project that we use our digital twin for as well. So in the same city model, we place our school student works as well. So another application is, of course, for our digital twin ecosystem is different research projects, and for any faculty in universities, I believe it's important. We found out that this digital aspect enabled us to really get more grants and attract more competitive funding. In any research that you do, if you add this digitalization aspect, if you add predictive maintenance, data analytics, and things like that, it typically helps to attract the funding. So, for example, in our faculty, we are working right now on 5 Horizon 2020 and Horizon Europe projects, which are top-level European research projects. One of them is called Precept, where we work with digital twins and energy management in a digital environments, and making our buildings more, let's say, predictive and proactive. D2EPC project is looking at energy certificates and how to make digital energy certificates dynamic. We have EU MAP project, which is looking at utilities management under quarantine and lockdown. And just recently, we've started a new project which is directly linked with digital twins and is aiming to boost our, let's say, capacity and research environment in the field of carbon neutral built environment and digital twins.
Methodology in the UK, which we use within our national digital twin, it's called Carver analysis. Okay, and Carver analysis understands that there is a network of everything is connected to everything else. Okay, a huge complex system of systems of interdependencies, and it takes us through an analytical thing of what parts of those networks are critical, how the accessibility of that piece of infrastructure impacts on that, how it can be recovered in the event of a disaster, how vulnerable it is to either disaster or criminal means, what effect that piece of infrastructure would have on the rest of the network, and how recognizable those things are. We have a table that allows us to go through and analyze that really simply. So, something is at a level 5 or level 5 criticality if it has a catastrophic impact on the country, if it's no longer available, and this asset will be of unique national importance. So that might be something like a nuclear power station, or a something that holds the nation together, all the way down through to infrastructure whose loss would cause moderate disruption. So it might just be something like a water pump that's broken in a water pumping station that's taking sewage away. Okay, so it's quite a critical piece of kit for that asset, but actually it's only going to affect a couple of hundred homes, and we've got a spare, and we can replace that within a couple of hours, so it's not too bad. And we do that by looking at all those assets and giving us a score, telling us how important assets are and how likelihood they are to be impacted by a natural disaster. So when we look at that priority, that important world, that also allows us to understand where our investment level should lie within a digital twin. So if you think of a rail network, it might be, well, we only needed a digital model of that railway station, but we need a twin of the track, and we need a shadow of the signalling system. So we can then work out where our money is best spent. So how can we do this better in a connected world? So we're going through this in a way that we can automate this whole thing within the UK at the moment. And we start by looking at the data sources we've got. We've got closed source information, which is owned by a client. We've got open source information, which is the stuff all over the internet out there. We've got things we can collect through drones, through aircraft, through unmanned ground vehicles, through satellite imagery, through live sensors. They're everywhere. Data is not a problem. We have so much data, but how we organize it is massively important. So we start with looking at all the different assets that we have within our environment, and we're looking at how we can do image recognition and automatic identification of assets from satellite imagery and from all those other sources. And then understanding that cross-domain sector functional and physical networks, we know how they all interdepend on each other. So that's just our starter for TEM. Building that circuit board and plugging in the various models, shadows or twins will then help us to understand how each of those areas impacts on each other in a much more detailed way. We can then carry out our Carver analysis, which is what I've just talked about, understanding where our governmental or our local investment priority will be. Where do we invest in our infrastructure? How do we invest in the resilience strategy? How can we make it more protective against the various pieces of various crises that might happen, whether it's natural disasters, etc. We can plug in previous flooding, erosion and climate analysis, giving us a climatic and disaster impact strategy. We can push artificial intelligence applied to live and historic data like side aperture radar or sensors embedded in the ground or seismic monitoring, and get to a point where we can automatically look at the condition impact and maintenance strategy across the board. We're also looking at how you can plug business and economic data and financial data in there so we can better support and we can better push business growth into the society and the economy as a whole, and how we can understand the optimal places to put industry to allow each of the supply chain to work efficiently with each other. And then finally, plugging in human networks, because if we understand where everything is, what the priorities are, and how we're going to grow that, it also allows us to understand which parts of which skills, what our education strategy will be, because we know what's coming in the future. We can then start creating those engineers and those people who are skilled and ready with the digital world to be in place when we create that infrastructure. It also helps us to understand things like housing strategy, which is a big problem in the UK, and also how we support vulnerable people within that society better. So being able to automate this will certainly improve the way we can run our country. But if we go right back to the very beginning of that, it's impossible unless we have good quality connected information. So the digital world needs digital skills, okay? And it's not just learning about what buttons they need to press, okay, on a piece of software. That's just the supporting technology. But it's all learning about the what, where, when, why, and how of those digital decisions. What information do I need to collect? Where do I need to get it from? Where do I need to connect it to? When is it relevant? When is it important? When is it needed by? Why do I need it? What questions am I going to ask? And what questions are going to need to be answered? And how are we going to deal with that? They need to understand that in relation to their digital skill, their digital world. So whether they are learning about construction procurement, whether they're looking at the legislation of the built environment, whether they're going into manufacturing, construction, whether they're going into management, whether they're going into the operational skills, or whether they're going into demolition. Digital will impact every single one of these, and if they understand that digital, they can become a much better employee, a better skilled person, and somebody who can enable that future. So, I mean, we use those digital skills to become more productive, to become safer, to become more profitable. I mean, bottom line, we're here to, people are there to earn money in this world, because that's what helps them to buy food, to put on the table, to go places, to enjoy leisure time, etc. So if we can make them more profitable, then we can increase their well-being. It's got to be holistic, and it's got to be sustainable when we look at climate and the environment.
Let me show you another point. So we are emphasizing on the term digital twin. So the key word is not digital. We have been using digital softwares for decades now. MicroStation is a 30-year-old product. So as AutoCAD probably. So we are all using digital workflow. We are not doing analog. So twin is the important part here, or important keyword here. Now the question is, why now? We had digital offerings since decades now. So why we are seeing now we have the digital twin opportunity? The answer is the advancement in technology. Today we have our cloud infrastructure provided by Amazon, Google, Microsoft. Today we have powerful hardwares like intelligent drones, a bunch of IoT devices, smart devices. Now, why do we call these devices smart devices? For example, we have a smart AC these days. There is as such no revolution in the cooling technology. It's same as it was 15 years back. Now what a smart AC can do? it can talk to you or your other devices remotely. There are features like which follows a person who is walking in a room. So there are sensors in the AC, and the ducts sort of moves as we move along the room. When you go out of the office, let's say you have 30 minutes to reach the home, you can sort of control your AC remotely from your mobile or some other device and instruct it to turn on and set the room temperature to 27 degrees. So that's why we call these kind of devices smart devices. And using digital twin, we can stitch a lot of smart devices together to create a smart ecosystem. We call it smart building, smart city, whatever is the context here. Take you through some of the benefits, key benefits of having an iTwin or a Bentley's implementation of digital twin. First of all, we have a single view of the truth. So we have created a digital version of our infrastructure. We can do a remote walkthrough. We can see the latest status of all the devices, all the sensors on that. So that helps in visualize, simulate, and do some predictive analysis and taking some improved decisions. For example, if we are tracking the cracks being developed on a road or a bridge, we can take advanced decisions. So rather than taking reactive actions, we can take proactive actions on our infrastructure. Now, this is sort of a composition of a digital twin. What all typical components are there in a digital twin? So as I said, there are engineering data which is synced to an eye model. Then there are other data, other metadata coming from different type of sources to form a proper eye twin. Now, as I said, that we have created an open ecosystem. So this is some of the examples where on the left hand side you can see some of the Bentley application file formats which can be synced to an eye model using free connectors. Then we have the third party vendors, third party with respect to Bentley. So Autodesk, Aviva, Revit. So all these file formats can be converted to iModel as well. And then on the extreme right, we have some standard interchange formats where you can read and write to from an iModel. So this is sort of a architectural or service level overview of the IT platform. So let me give you a quick analogy. So you all use smartphones, either Android or iPhone. So when Apple, let's say, created iPhone, so they launched a sort of a development toolkit as well, using which third-party developers can create wonderful apps. At the same time, Apple also created some in-house apps. For example, the phone app, the calculator app, or let's say some complex example, GarageBand. It's a professional level video, audio editing software, or Office equivalents apps, Pages. So those are created by Apple. But there are million more external developers who have created apps using Apple sort of toolkit, development toolkit. It's exactly similar to our iTwin platform. We have created the platform with bunch of these different services. Our in-house Bentley engineers, they have created a lot of apps targeting to different verticals. But we are envisioning that there will be much more use cases out there where third-party developers or software vendors will leverage our iTwin platform, consume one or more of these services, and create a workflow or app of their own. And the possibility is limitless there, what they can do. And from Bentley side, we will be adding more and more services here.